For the past couple of years, the AI story has felt like one shocking breakthrough after another, right? But the real revolution, the one that's actually changing everything, well, it's not about the hype anymore. It's about something called hyperscale. So let's dive into this crucial shift from flashy demos to industrial reality. And this quote just nails it. It's like the wow factor we used to get from a new model release. That's kind of gone. Now what really matters is something way more important. We just expect these tools to work, reliably, at scale. So, you see, the big story of 2025 wasn't some flashy new invention. Nope. It was all about industrialization. And when I say scale, the progress was just staggering. I mean, get this, in just 12 months, the amount of information a model could handle at once, what we call its context window, it didn't just double or triple. It grew by a massive 78 times. We went from 128,000 tokens to 10 million. To put that in perspective, that's like going from being able to read a short novel to swallowing an entire library in a single gulp. All right, so that brings us to our first big idea here. AI is getting serious. In 2025, we didn't really have a single ChatGPT moment, one thing that blew everyone's mind. Instead, what we got was this relentless drumbeat of progress, a sign that AI was really growing up. So, what does that actually look like? Well, for starters, those super smart reasoning models, they became standard features, not some expensive add-on. In video generation, it went from just making funny memes to being a serious tool for professionals. And you're not going to believe this, humanoid robots finally hit a price point where a regular person could actually think about buying one. And if you look at the timeline for the year, you see this one theme over and over again: an explosion in scale and the sheer amount of infrastructure needed to back it up. I mean, look at January. The Stargate project was announced. That's a data center that needs more power than all of New York City. Just let that sink in. Then, boom, April hits, and Meta's Llama 4 comes out with that massive 10 million token context window we talked about. By the time we got to the end of the year, global spending on AI data centers had hit a whopping $61 billion. And all of this really paints a clear picture of our new reality, doesn't it? The bottleneck for AI isn't just about who can write the cleverest code anymore. Not at all. Now it's about physical things, power, land, actual raw materials. And that reality leads us to a massive, critical question, one that involves the entire planet. Okay, so this is where things get really interesting. We're talking about Earth's compute limit, because this insatiable demand for more and more AI is starting to smack right into some very real, very physical limits of our planet. And these limits are all hitting at once. First up, you've got power. In a lot of places, the electrical grid is basically sold out. If you want a new hookup for a massive data center, you could be waiting years. Okay, so then there's land. Just trying to build these huge facilities is getting bogged down by permits and, people not wanting a giant power-hungry building in their backyard. And then there's water. Oh man, the water. A single big AI data center can guzzle 2.5 billion liters of water a year. That's just for cooling. That's the same amount of water that about 80,000 people use in an entire year. It's nuts. So that leads to a question that honestly sounds like it's straight out of a sci-fi movie, but I promise you it's being asked in the boardrooms of the biggest tech companies on the planet right now with dead seriousness. The question is this: if we're running out of Earth, where the heck do we build the cloud? And the answer they're coming up with, well, it's every bit as ambitious as it sounds. We're talking about the space data center. And look, this isn't just some crazy theory on a whiteboard. In late 2025, the Starcloud 1 mission actually launched a satellite with a high-powered NVIDIA GPU on board. And they proved it. They ran a large language model in orbit. Now, it was a small step for sure, but it was pointing towards one heck of a giant leap. Okay, so right about now, you're probably thinking, wait a minute, space is freezing cold. Cooling these things should be a piece of cake, right? It's a super common thought, but it's actually a total myth. The reality is that a vacuum is a perfect insulator. See, here on Earth, we use air and water to whisk heat away. But in space, the only way to get rid of heat is through radiation. And that turns out to be a really, really tough engineering problem to solve. Just how tough? Well, let's say you want to cool a 40-megawatt data center up there. You would need radiator panels, just panels, to get rid of heat, with a surface area of about 120,000 square meters. It's hard to even picture that, but think of it like this. That's about 15, maybe 20 football fields. An area that huge with its only job being to just radiate heat out into the blackness of space. So you might be asking, why on Earth, or off it, is anyone even considering this? It all comes down to the economics, which are changing like crazy. Right now, it costs about $5,000 to launch a single kilogram into orbit. But with new rockets like SpaceX's Starship, the projected cost drops to just $500. And all of a sudden, launching hundreds of tons of hardware into space goes from science fiction to economically plausible for the first time in human history. And hey, what about just building on the moon? Well, that's an even tougher nut to crack. You've got a brutal 2.6-second delay every time you try to talk to it from Earth. You have 14-day-long nights with zero solar power. Plus, the radiation is way, way worse. So for now, that makes these orbital data centers let's call it the more realistic goal. And yeah, I'm using the word realistic very loosely here for what is still an absolutely mind-boggling challenge.
Okay. Let's pull this conversation back down from orbit for a second. Because while some folks are planning for data centers in space, most businesses on the ground are asking a much more practical question. With all this insane power, when does AI actually, pay for itself? And fintech is the perfect place to see this in action.
See, for any business, the choice isn't just should we use AI. It's a real strategic decision with a few different paths. The easy route, you can just plug in a generic API, something like GPT-4, and get it running for customer support in a matter of weeks. A little more involved, you could fine-tune an open source model with your own private data. That takes a few months, but it gives you a decent competitive edge, perfect for something like credit scoring. And then there's the hardcore option. Spend a year or more building your own proprietary model from the ground up. That's how you build a really strong defensive moat, ideal for something like system-wide fraud detection.
But here's the kicker. At the end of the day, it all comes down to one thing: scale. That fancy AI fraud detection system, it really only starts to make financial sense once you're processing over 50,000 transactions a month. That AI-powered credit scoring, you need to be looking at 10 to 20,000 applications a month for it to be viable. If you're below those numbers, the huge costs of AI often mean that, honestly, the old-school ways are still cheaper and probably better.
So this gives us a really simple but super powerful set of questions that any leader should ask before they jump into a big AI project. Number one, do we actually have the volume to make this worthwhile? Number two, do we have special proprietary data that nobody else has to give us an edge? And number three, what happens if the AI screws up? What's the cost of failure? You got to answer those three questions honestly. That is the key. All right, so let's tie all of this together. We've talked about this huge industrial progress, the very real physical limits of our planet, and the cold, hard economic facts. It all points to one thing. We are now playing by a completely new set of rules, and those rules are all defined by one word: scale. The whole conversation we're having about AI has just done a 180. It's not about who has the cleverest algorithm anymore. It's not about who has the coolest demo. The game now is about something much bigger. It's about who has the industrial power, who can get their hands on the physical resources, and who has the deep pockets to operate at the massive scale you need to actually win. And so that leaves us with this one last big provocative thought to chew on. The most important question for the next era of AI isn't what's the next cool AI model. No. The real question is, who can actually afford to build the world that this AI needs to live in? And that's a question that isn't about code. It's about power, money, and physics. And the answer to that is what's going to define the next few decades.